At this point, I have a custom device type with tags assigned to it, but no register addresses assigned. To begin, under Real-Time Tags, I'll click Edit on my first register with the Modbus register list in hand. At the top of the page, I have the tag's name and its unit, both of which are assigned with the tag. If I need a tag in a different unit, I'll have to create a new tag. The same goes for the data type. This tells me that this tag is stored in the software as a 32-bit floating point value inside the database. Don't be concerned if your value on the device is not in this format. The driver packs most analog values in real tags. The other common data type is a digital, which stores a Boolean value of 0 or 1. Some special values are also stored in long registers. If you're concerned with tag types, I'll refer you to the System Guide section labeled Logic Code Definitions for more information. Technically, we can set the priority for how quickly the Power Modbus driver scans the tag on the device. But in reality, this is generally overridden by the driver's block read parameters, which we will discuss in detail when we get to troubleshooting. More importantly, we need to pick a logic code, which is how the data in the register is organized. This information comes from the register list, where I see my current is stored as a float 32. Which is an IEEE real value. This is easy enough to find. If the register stores an integer value, I can choose either scaled register signed or unsigned. The other codes, as well as the advanced logic codes, are used for more specialized circumstances. Again, please check the system guide for more information. To the right, I can choose either holding for a 4x register type or input for 3x. The Power Modbus driver only stores addresses in decimal format, but I can choose hexadecimal here to copy addresses from the register list more easily. Profile Editor will convert them to decimal automatically. The number of registers here is grayed out because we selected a 32-bit real value, which is always 2 registers. Scaled register values can be up to 4 registers long, so we would need to include this information. Now I can finally enter the register addresses, 3000 and 3001. While we're here, let me point out that this addressing will need to be tested once the device is added to our project. There are many components of addressing that can go wrong, and register order is especially problematic. I also have options for scaling the register value. The fixed scale is applied in powers of 10. If I enter -3 here, the value will be read from the Modbus registers, then scaled down by 10 to the -3rd power, dividing by 1000. The register scale works in the same fashion, but instead of a fixed scale value, the scale is read from another Modbus register. While scale is in powers of 10, the conversion factor is simply a multiplier for the register value. Finally, the offset is added to the value. Note that these options are added in this order: scale, conversion factor, then offset. At long last, I can click OK and see the settings I've applied. let me show you something interesting. If I select Settings, Display Advanced Properties, I can see the tag address I just built. This is the actual string containing everything we just entered that will be added to the database for this tag. While it's not critical for you to be able to read these addresses, it can be helpful in troubleshooting communication issues later. This will come with time. We're not done with our addressing yet. I'll go ahead and add the addresses for my remaining analog values, and in the next video we'll add that status input. Until then, thank you.